All right, let's just dive right into it. Welcome to this explainer, where we're going to explore this magnificent, fully automated factory running constantly inside your chest. We're going to track the exact microscopic journey a breath of air takes from the moment it enters your body to the split second it keeps you alive. It's a system of such high-level, intricate engineering that it's honestly kind of hard to wrap your mind around sometimes. Yet it's happening right now, continuously, without you taking even a moment to think about it.
Actually, hey, let's try a quick experiment right now. Take a deep breath and just hold it. Seriously, keep holding it. While you hold that breath, we're going to explore the biological marvel that is working tirelessly to keep you alive. You can release it whenever you need to, obviously, but feeling that mounting, unavoidable urge to breathe, that is exactly the mechanism we're breaking down today.
Section 1. The Gas Exchange Station. To understand how this whole operation works, we first need to look at the massive organs responsible for the process, your lungs. Now, you'd probably assume your lungs are just perfect mirror images of each other, right? Like identical twins sitting in your chest, but they're actually not. Notice how the right lung is noticeably larger, and it's built with 3 distinct compartments or lobes. Meanwhile, the left lung is slightly smaller and only features 2 compartments. And this isn't a mistake. It's a strict architectural necessity to make room for another vital organ we'll talk about in just a second.
But first, we really need to touch on a rather stark reality of modern life. If you've ever seen animal lungs at a butcher shop, you know they're naturally this vibrant, healthy pink color, and they have a very soft, almost sponge-like texture. But human lungs today often tell a much darker story. Because of heavy industrial pollution, daily vehicle exhaust, and years of inhaling various kinds of smoke, that natural pink appearance is frequently altered over time. The tissue literally transforms into a slate gray color, completely covered in dark, soot-like spots. It's basically a physical record of the air we navigate every single day. So, before we go any deeper, we've got to bust a few common myths about how these organs actually draw in that air. Lungs do not work like simple balloons or football bladders that just magically inflate and deflate on their own. And they definitely don't operate like a blacksmith's bellows, forcefully pushing air around with internal hinges. The reason those comparisons completely fail is that lungs actually lack the internal muscles required to pump themselves. Instead, their inflation is tied to a highly complex biological vacuum system intricately connected to the physical expansion and contraction of your entire chest. Which brings us perfectly to Section 2, inside the chest cavity.
Let's look at the physical space where these 1-pound organs reside. Human biology features 3 distinct, tightly sealed compartments constructed right inside the chest. It's a remarkably organized, highly secure setup. You have 2 outer compartments where each of the lungs hangs individually, totally isolated from one another. And perfectly nestled right there in the middle, safely sealed off in its very own central compartment, is where your heart beats. And this is exactly why that left lung is smaller. It's physically making room for that central heart compartment.
Now, the reason these separate, deeply sealed compartments are absolutely crucial all comes down to basic atmospheric physics, specifically pressure. Since your lungs can't move themselves, they rely entirely on a delicate vacuum seal within these compartments. When your chest expands, it creates negative pressure that pulls the lungs open, physically sucking air in. If this precise, delicate vacuum seal is ever broken, say by a traumatic penetrating injury to the chest wall, the lung will instantly collapse. It'll just hang there, a totally useless lump of tissue, completely unable to draw breath until the physical wound can be sealed up, healed, and that vital vacuum pressure is perfectly restored. Section 3. The upside-down tree. Now that we understand the housing and the mechanics of the vacuum pulling the air, let's trace the actual physical pathway air takes when you inhale. When you pull in a breath, the air travels incredibly fast down a 4-inch windpipe, known scientifically as the trachea. The air is moving at its absolute fastest here. But then, this main pipe splits off into 2 primary bronchial tubes, one heading straight into the right lung, the other into the left. From there, the air begins to slow down as it enters a process of continual, massive division, branching out into smaller and smaller and smaller pathways. I absolutely love this analogy because it is just a perfect way to visualize the internal architecture of your chest. Imagine a massive, sprawling oak tree, but flip it entirely upside down. That 4-inch windpipe we just talked about, that is the thick trunk at the top. As you move down, it splits into heavy branches, which split into thinner branches, and so on and so on. By the time the air reaches the countless microscopic branches at the very bottom, those pathways have narrowed down to an astonishing 1/100th of an inch thick.
But here's the thing. This upside-down tree isn't just a passive set of hollow pipes. It is a highly advanced active filtration plant. As the air rushes through these tiny branches, it's constantly being filtered, warmed, and conditioned. The inner walls of these biological pathways are lined with a protective mucous membrane, sticky water-like fluids, and a dense, waving layer of microscopic filtering hairs called cilia. They all work together simultaneously, like a giant industrial scrubber, to grab onto dust, toxins, and impurities, making sure that the air is perfectly clean and prepped for the critical next step.
Section 4. The microscopic miracle.
Let's zoom in even further to the absolute end of these microscopic branches. This is the main event. This is where the actual life-saving magic happens. At the very end of the journey, the deeply conditioned, perfectly warmed air finally reaches these tiny grape-like sacs called alveoli. These act as the ultimate microscopic gas exchange stations of your entire body. And wrapping tightly around every single one of these microscopic sacs is a dense, incredibly intricate net of tiny blood vessels called capillaries. This is exactly where the air you just breathed in finally meets the blood pumping from your heart.
Okay, this next fact is absolutely staggering to me. You might be wondering just how much actual space we're talking about inside your chest for this exchange to happen. Well, to maximize efficiency, your body packs an unimaginable number of these tiny alveoli together. If you took all of the alveoli functioning in your lungs right now, carefully unraveled them, and spread them out flat on the ground, they would cover the surface area of half a tennis court. All of that incredible surface area is folded, packed, and perfectly arranged right inside your ribs. Isn't that wild?
And the speed at which this factory operates? It's mind-blowing. The capillaries wrapping those tiny sacs are so incredibly narrow that your red blood cells literally have to politely line up in single file just to squeeze their way through. As they pass closely by the very thin membrane of the alveoli, they drop off carbon dioxide and instantly pick up fresh oxygen. That entire complex chemical exchange, it takes exactly half a second to complete.
You know, you can actually visually track this half-second miracle just by looking at the color, which is fascinating. When the blood cells first enter the capillary directly from the heart, they look blue because they're heavily loaded with cellular waste, specifically carbon dioxide. But in that brief half-second, as the carbon dioxide is absorbed across the membrane to be exhaled, the cells quickly fill up with fresh, pure oxygen. By the time they exit the capillary, their color has completely transformed into a vibrant, brilliant cherry red, ready to be pumped back out to fuel your muscles, your brain, and your entire body.
Finally, Section 5. The autopilot system. Now, looking at this incredibly complex, sprawling factory, you might be wondering how much conscious control we actually have over it. Most of your organs, like your heart or your stomach, work entirely on their own. You can't just decide to stop your heartbeat, right? But breathing feels a bit different. You can hold your breath, you can breathe faster, and because we have this illusion of control, we've all seen or at least heard of a highly frustrated or stubborn child throwing a massive tantrum and holding their breath. They hold it until their lips physically turn blue and they reach a state of near fainting. It naturally causes absolute sheer panic for the parents watching it happen. But is this actually a fatal danger? Can you consciously turn off the factory?
Well, it turns out the panic is entirely unnecessary. Your lungs largely operate on a brilliant, deeply ingrained self-regulating system. If a child holds their breath long before any real permanent harm occurs to the brain or body, your automatic fail-safe forcefully takes over the controls. The autonomic nervous system simply steps in and makes the child take a deep breath, whether they want to or not. The system is fundamentally rigged to save your life, entirely overriding your conscious stubbornness.
This quote perfectly captures why this entire explainer is so endlessly fascinating to me. Breathing is a fundamental skill, programmed right into your biology while you're still developing in the womb. From the very moment you were born, entering the world with that first crying gasp of air, this flawless, staggering system kicks right into gear. It operates on autopilot, day and night, awake or asleep, entirely without your conscious supervision, until the final count of your breaths is complete.
So, I want you to take one more deep, intentional breath right now. Feel your chest physically expand, fully knowing about that delicate vacuum seal, visualizing that massive upside-down tree, picturing the half-tennis court of surface area, and imagining that single-file line of vibrant cherry-red blood cells. Truly appreciate the magnificent biological engineering happening inside your chest at this very moment. As we wrap up, ask yourself, just in the time it took to watch this explainer, how many thousands of half-second microscopic miracles did your body quietly perform to keep you alive?